All yours.
Okay. So the admin console is pretty much where you start with the Nexus dashboard, and is where you would go to import your new ACI on an XOS fabric. Very simply, you would go Manage, Fabrics, and here you can see all the fabrics that are currently living inside our Nexus dashboard. And if you do want to add or remove one, you can just go on the Add Fabric, pick the type of the fabric you want, put in the credential, and onboard the fabric inside your Nexus dashboard. Once this is done, we can then go and take a look into our insight. And the moment you log in, you get a nice overview of how are your fabric distributed across the globe. And if you scroll a bit down, you start to get a very high-level insight of how things are going. You're going to see that, sadly, our anomalies are going up, for example. So you probably want this to, in production, to either be static or going down. You're going to see how many fabric we have, that in this example is 4, and that in total across all our fabric we have, for example, 261 endpoints. Just high-level overview. Scroll a bit more down, you get here a view of fabric by fabric, again a summary view, how many endpoints, neighbors, switches are present, and you can just easily scroll to get an idea of your various fabric. And then if we proceed down, we get a breakdown of our anomalies and advisory, and what are, we will cover in a bit, but anomalies are, as the name implies, something that doesn't look quite right in our fabrics. And advisory are things like PSIRT or bugs that we detected and we think that they can be affecting our fabrics. We also have a breakdown of the external traffic. So this is the traffic that comes in and out of our L3 outs. And it's, again, quite useful to get an idea of what's going on in our fabric. Is the amount of internal, external traffic being steady, going up or down? And you can give us an idea on the usage of our data centers. Now, let's go and pick, for example, our production fabric and take a look and see what we can learn about it. So we can say, for example, click on View Topology, and this will bring up the whole view of our fabric. So here we can see that it's a fabric where we have 4 leaves. To these 4 leaves, we have connected our epic. They go to a spine called 203GX, and then this spine is then connected to an N9K that in this case is running standalone and is acting as like our IPN in case we are doing multi-pod, multi-site, and so on. If we go back on our global view, we can then jump again into our fabric. Whoops. And we can go fabric details. And now here, we go on a breakdown of the detail of this specific fabric that in this case is called production. So what can we see here is an overview that overall this fabric has 280 interfaces. Of these 280, 76 are up, 202 are down, nothing crazy. And now, for example, we can have a view on the software that this fabric is running, how many controllers, how many switches we have, and we can go and have a look, for example, at our status from a hardware resource and a capacity resource. For example, if I click on hardware, here is going to give me a breakdown, for example, on our CPU level. So if we want to monitor CPU, memory, or temperature, we can just click on the different option to get a snapshot in a graph. And if we scroll down, we also have a nice breakdown on a per switch basis. We can do the same thing from a capacity perspective, and this is like a scale, right? How many bridge domain, how many contract am I using across the whole fabric? Or we can go and drill down on a per switch level. Again, this becomes extremely useful if you want to, for example, do forecasting, right? Maybe the number of IP is steadily increasing in our fabric, and we might need to add more switches, or the usage of our interfaces. If we go a bit down here, you can see we have interface resources as well. We can see how many ports are being used. And if you're starting to see they're running out of port, maybe it's time to go and buy a new switch to expand your fabric capacity, and so on. We can also click on switches, and this will bring up the view of all the switches in our fabric, where we can get a generic idea of the health of the switch. Now here, everything is either critical, major, or I'm exploding because it's a lab. So I bet nothing, for example, has the secondary power supply plugged. At least my lab, it's always one power supply, so it's always red. Then we can click on one leaf, and that again will bring us down into the detail of our leaf, where we can see again a high-level view of the switch. We have again the view hardware and capacity resource. That is the same as what we were seeing before, just there was like drilling down from global to, and then being able to pick a leaf. Here we are already in a leaf, it's just a shortcut. But we can also click on an interface, say I can click on this uplink, and here we can see the detail of the interface speed, if it's up and down, but also go on trend and statistic and see the status of how much, if we are getting error, traffics, and this is all streamed real time. As the data comes in from ACI or NXOS, we get pretty much the same look and feel. You get like an overview of the traffic. Again, very useful here if you want to have a trending history to try to troubleshoot or do forecasting of your resource utilization. Then we can go and take a look at the connectivity tab. And in the connectivity tab, you have an idea of how this specific leaf or switch in general connects to the outside world. We can have a view on the interfaces that are configured on the specific switch, as well as an easy way to see which one are our CDP or LDP neighbors. We can go on L3 neighbors, and this will show you the status of all your BGP and OSPF peers. And what is very nice, for example, for BGP is that if you click on it, you also get an information of how many prefixes are sent, received, how long has been the uptime of the connection, so you can have an idea if it's stable or not, as well as what are the BGP capabilities that you're receiving from your neighbors. So very easy to kind of monitor and keep track of how your network is behaving. Then we have, again, another view around endpoints. And this will track how are the endpoint health how the endpoint that connects to this leaf are behaving. Are they healthy, unhealthy, how they are connected, and so on. So in here, if, for example, I pick an endpoint, 68, a specific endpoint, you can see that it's going to tell you the name of the endpoint. Now, this happened because NDI can integrate to an external DNS. So now, as we learn IP addresses, we do periodically DNS lookup to check, oh, what does this map to? So we can get a nice host name to identify our endpoint. And then if we click on the IP address itself, it's going to also be able to tell us the history of this endpoint. So if you click on the IP history, you can see that, for example, today at 11 something, we had a change of the interface from where this endpoint has been learned to. And that happened because Domenico did a vMotion. This is a virtual machine. It vMotioned from one host to another. And what is also quite nice is that since we can also integrate with vCenter, we are also going to tell you that we detect that the change was from one host to another. So in one single place, you can say, oh, yep, this IP changed. It moved from this port to this port at this time. And since it changed hypervisor, most likely was just a vMotion. So nothing to be worried about. What is more interesting would be if you say someone tells you, oh, I have a problem with this application. It doesn't work very well. You go here and you see this IP that keeps changing, maybe every few minutes. That could point out to some instability in either the network or maybe this VM keeps getting vMotion due to some strange reason, and you can use this information to go and drill down on what's the problem. We also have a tab around anomalies. Now, in this one, there is nothing wrong. because this endpoint is healthy. But if there was something wrong with this endpoint, say it was a duplicated IP, or it was keeping flapping all the time, or traffic was dropped for this endpoint, in here we would have an anomaly that will tell us, hey, there is something wrong, and you can go and check what's happening. Other things we can see in here, it's in case your switches are part of a VPC domain, it will give you an overview of the VPC domain status of the switch. And we get also a view on status of multicast, so your IGMP groups status. You can also go and view the statistics of your ICMP groups, as well as having a view on your multicast routes. All right, so if they're present in the fabric, they will be here. So this is a bit of a generic overview of what we can see from here. If we go on our integration, just to give you an idea, when I was speaking about we integrate with DNS, here is where you would integrate anything that is external. You can also see that we are integrated with things like AppDynamics, NDO, as well as vCenter. If you click on any of the integration, and you can go and drill down and see info, for example, about your VMs. This can be very useful because you have one place where you can do troubleshooting on the classic case, my application is slow. If you know the IP, thanks to this integration, you can find out the IP to which VM it maps. And here you can see there is a virtual Nexus dashboard running in this vCenter, and you can see how much CPU it was consuming, or how much memory or storage or network usage this specific VM was using, and you can use this info to then understand is the VM healthy, or there might be something problematic with the VM, and so on. And you also here get a list of the virtual machines that are running inside your virtual environment. And this it makes, hopefully, the life of the network admin a bit easier, because then you don't have to go and ask the VMware team to, oh, please, can I have access to vCenter, or can you check how this VM is behaving? And we only need read access. So also from a credential perspective, the only thing they need to give you is a read-only access to ingest this information inside NDI. Now let's speak about anomalies, because anomalies are one of the most interesting things of NDI, right? What we're showing now is more statistic. There are statistics coming in, we can explore our statistics, that's cool, but statistics alone sometimes don't tell the whole story. Sometimes we might have issues that are breaking our connectivity that we need some help to troubleshoot. Now, anomalies follow the exact same structure regardless of what are about. So if you're running ACI and XOS, or you get an anomaly from vCenter, as the last one in here, they all follow the same type of structure. They will tell you what's wrong. So in this example, it says, I have a VRF in enforce mode, and a bridge domain subdomain is advertised outside of this, but the EPG belonging to the BD do not have any contract. Now, is it wrong per se? Probably not, but if you're advertising a subnet outside of the fabric, then why you don't have a contract to allow any communication, right? At minimum, it's suspicious. So here it tells you what's wrong. Then it's going to tell you what is triggering this anomaly. So what are the object or the configuration pieces that are creating the problem? So in this example, it tells you we have a bridge domain in the tenant PCV. The bridge domain is 192.168 something something, and this is the L3 out where we're advertising it out. Then it gave us what is the impact, and then lastly, it will tell us how do I fix it. Now, depending on the anomaly, obviously the text inside this different portion or section will be different, but they all follow the same type of structure, right? So what's wrong, what triggered, what's the impact, how do I fix it? And this is what you can then use to try to narrow down your issues and potentially even fix it. Also, anomalies can be assigned to, so you can use NDI kind of as not a ticketing maybe tool, but you can at least assign them to user to then have them investigate. And we also have a plugin for ServiceNow where as anomalies are detected, they can also open ticket automatically. Another type of anomaly that are quite nice is if you're running flow telemetry, where your fabric are sending telemetry data of the flows that are happening in your fabric back to the fabric. If we detect that, for example, there is a drop, for whatever reason, we will also raise an anomaly. So here we have a flow event anomaly called forward drop. If you click on this one, again, pick a random one, it will tell us there is a packet drop detected due to forwarding drop on the specific leaf. What does it trigger? Well, a packet has been dropped. This is not particularly advanced, but it's also going to tell us the impact. So it says at least 20 flows are impacted. If I click on View Report, it will pull up and show us all the IP addresses of the flows that are being dropped. So that's super cool, right? You're like, oh, wow, what's going on here? And if you can see, you have all these source IP addresses trying to reach these, for example, 255 address and so on. Now, what is a forwarding drop? Is a type of drop where we don't know who is the next stop. We are trying to send packet to an IP that we don't have a route for. So it's going to be dropped. So what's the solution? Well, you should check the destination subnet if it exists in the VRF. So you don't have a default route or you don't have a route for that subnet. So the switch is like, meh, drop, right? Now, another type of things that we detect are advisory. Now, advisory, they are similar to anomalies, but not exactly the same. They are more around like configuration best practices, PSIRT, or potential bugs. Just to give you an example, here I'm going to do one from an NXOS fabric, where the best practice, by the way, best practices only exist for NXOS. We don't have this type of advisory for ACI. It will tell you, oh, you don't have centralized logging configured. As a best practice, you should always have centralized logging, and it's going to tell you what are the switches affected in the configuration and how to fix it. It will tell you, oh, to fix it, you should open this link, and here it will give you like some information on how configure centralized logging on an NXOS. And off you go, right? We have another example, could be hardware end of life. It's going to pull up and say, oh, we have this leaf that is going to be end of life in a specific amount of time, and so on. Now, let's continue and let's move to what we call the Analysis Hub. Now, Analysis Hub, it's just a central tab where we then collapse a lot of different cool small apps, or if you want. Some are ACI only, some are ACI as well as an NXOS. I will not going to show you all because a few we're going to show you in the demo, so they will pop up as we go on with the presentation. The first one I'm going to give you a look is the bug scan. Now, the bug scan is pretty cool. The idea with the bug scan is that periodically, we are going to collect a show tag from every single device in our network. Then we analyze the show tag against a set of known bug signature. Now, a bug signature is something like in this log file, there is this message, or in this ASIC counter, there is this amount of, it's increasing, something like this. And depending if the signature is a match, we are going to tell you that you are either susceptible to the bug or active. So the difference is if the signature is a good match with what we're seeing in the show tag, the bug is actually active. So in this case, the active bug would be SSD upgrade app, blah, 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 something. If you are susceptible, it means that you're running a version that could be affected by this bug, but the signature is not triggered. So for example, maybe there might be an OSPF bug, but you're not using OSPF, so you are susceptible to the bug. But if you don't use the feature, no problem. Right? Now, also for the bugs, we're going to give you a bit of a description, the bug ID, and then if you click on the bug ID, I'm not going to do it now, it's going to anyway teleport you to the cisco.com bug list where you can get the detail of the bug and so on. Then we have another feature, slightly complete different set of things around the sustainability. And this is give you an estimate of the power consumption across your data center and also how much CO2 emission you're doing. The way it works is that we pull grid statistic data from an open database that will tell you, if you are in the Netherlands, more or less this is the split of energy between renewable and non-renewable, and we try to make an estimate of how much CO2 you emit, and also we pull in the average cost of the energy in the country where you live, and we're going to give you a daily cost estimate. Moving on, another interesting feature is around conformance, and the idea of conformance is pretty much give you an idea of around your hardware, software, and scale, and see how you're going. What I mean is, let's say we pick hardware and software, and you want to know a few months ahead if you're starting to going to have software that is going to be end of life, end of support, or hardware, end of life and end of support. So in here, you can get an idea that from a hardware perspective, for example, as of today, we have 2 Epic servers that are critical, meaning they're completely end of life, end of support, and you should change it. And then everything else seems pretty healthy. But what's going to be in 18 months from now? So you can change just this setting, and then you're going to see that in 18 months from now, also this leaf is going to be out of support. So you can go and start to plan like a refresh cycle for your hardware. And you can do the same thing for the software, but same. Then we do the same thing for scale. Now, everyone here is aware that there are scalability guides for both ACI and XOS. They're not hard to understand. They're a bit more annoying to track because you need to remember to check and so on. There is at capacity dashboard in ACI, but again, if you have multiple fabric, you don't have a centralized way to track all of this. So in this conformance report, we are going to tell you the overall scale at a, let's say, fabric level as well as a switch level. So in here you can see, if we scroll down, that from a fabric perspective, we are monitoring, for example, in this prod fabric, 14 controller metrics, so configuration from an Epic perspective, and 86 metrics from the switches. And if you click on a metric, it will pull up and it will tell you, oh, Leaf 101 can support up to 24,000 MAC addresses, and we're using 184. And we're going to do these for everything in our fabric. This is more of a making your life easier. It's the log collector. The idea of the log collector is I'm opening a tag case. I need to upload a show tag. I can go here, select my switches. So in this case, I've selected these 3 switches, and then you can run a show tag, and once it's collected, so here I didn't finish it, but once the log is collected, you can say upload all file. This will upload the file to Intersite, and then TAC will have all the log file. And then last thing I'm going to show you, and then I'm going to pass back the stage to Domenico, is around PolicyCam. Now, this is specific for ACI, and I'm not sure what's everyone experienced, but I know of many customers where you have big fabrics with a lot of contracts, a lot of changes, and then over the year, you start not to know anymore what's going on from a contract perspective. Am I still using all the contract? are applications still needing specific contract? It becomes a bit hard to track things. So the idea of the policy CAM analyzer is twofold. One is to give you an idea how your TCAM has been used across all your fabrics. So here you can see that, say, in the AI Ops tenant, as a provider, I'm using 120 TCAM entry across my whole fabric. Of these 120, if you click on it, the only consumer is the same tenant. Then within the AI Ops tenant, you have a list of EPGs that are using, say, 16 TCAM entry each, and so on. And then we break it down all the way down to the filter, but also down to the leaf. So you can really, in a very easy way, understand, okay, I have all this set of contracts. They're using a lot of TCAM maybe globally, but maybe very little on the leaf, while you might have one contract that globally is not using a lot, but maybe is killing one of your leaves because it's a huge contract that might need optimization. Another thing that we can do with the TCAM analyzer is also seeing how the policy CAM is distributed across the switches and if there are hits on the TCAM counters. So for example, in this table, if we scroll all the way on the right, where it is, sorry. I went too low. So on the table before called policy CAM statistic, here you can see that you can sort your contracts by policy CAM usage, or more interestingly, by hits. For example, cumulative hits. So here you can see that I have a specific contract in VRF3 that is called, say, backend 3 to frontend 3 contract 1 that is using just 2 TCAM entry, so not that much, and in the last day has been hit a big number of times. But there are other contracts that have not been used in the last week, or even worse, has not been used in the last month. Now, if you have contracts that have not been used in months, then why do I still have them? Why are these contracts still there using TCAM space? So what you can do is that you can use this type of data to then go and optimize your ACI fabric. We also have an Ansible playbook, but you can do it also with API, that you can dump this table out in a CSV file to then kind of make it a bit easier to parse and understand which contract can be then removed or optimized. Also, this is very useful if you're evaluating to use contract compression. That is a feature of ACI that can reuse the same contract across multiple EPGs without having to program it over and over again. So you could say, maybe I don't want to enable it for everything. I want it because you lose statistic when you do that. But if you have contracts that are really giving you a big hit on your TCAM consumption, you can use this tool to identify them and then decide to use them for this type of optimization. So that's pretty much a generic overview of the UI. There is definitely even more around it, but it gives you just a bit of an idea. And, oh, sorry, forgot one part. We also have Search and Explore. Now, the idea of Search and Explore is that you can use kind of natural language queries to look at your ACI fabric configuration. The idea would be you can ask things like, so let's pick a fabric, and you can say things like, can EPG backend 1, and you can say talk to any. And then it will go and tell you if this EPG can talk to other, and if so, how it can talk to. So it's very useful to understand, like when you're troubleshooting, for example, connectivity issue, you can say, can this endpoint or can this EPG talk to this EPG on this port? And it will get an answer right away. You can also use it to explore your configuration. You could say, where is bridge domain deployed? Or where is this VLAN deployed? Is it deployed on these ports? And so on. Right? And this is an ACI-only feature at the moment. All right. So that's actually now conclude what I wanted to show you around the UI. bit of a high-level overview, but this is also available in dCloud, so if you guys never saw it and you want to play with it, there are like labs on dCloud where you can log in and play around with it. Now I give back the stage to Domenico, that is gonna, oh, thank you. We're not done yet, though. Still have half an hour.
Thank you, Camillo. It was very, very interesting. I hope you enjoyed at least this first part of the overview. We gotta now go into some other demos, right? So more live use cases. So this was just an overview of the UX, the user experience that you can have with NDI. Some of the capabilities, right? So not all of them. The thing is that we built some recorded demo just to kind of make a few use cases where something goes wrong or something I want to troubleshoot. How would I do that? A couple of words before I move that. So it was a great demo. Thank you, Camillo, for that. I really enjoyed it, at least myself. Hope the same for you. Couple of comments. So about the CAM utilization, right? So the CAM analyzer that just showed. I've got quite a few customers also that use this tool to optimize, as Camilo was saying, their fabric configuration. One of the nice things is that I don't have any in my fabric, right? But if you have, for example, in ACI contracts which are overlapping with one another, and that happens quite often. Many of my customers have that. NDI will spot that and will tell you, look, you've got some contracts which are not optimized. You're actually using, policy or contract which are overlapping, filters which are, doing the same and consuming TCAM entries to actually program the same policy across the different switches. So this is, I think, a super useful tool. And by the way, Camilo was mentioning rightly, right, that there are some things which were only available for ACI. For example, the policy CAM today is only for ACI. Something else he mentioned only for an XOS. Indeed, if I go back to my slide previously, there are this bubble here in the center is what we can do today both for ACI and an XOS. There are some things which are mostly technical differences between the two platforms, and that's why we do only for ACI or only for an XOS. But we've got a roadmap, both from the switch standpoints and also from NDI standpoints, to make it all in the same bubble. So the idea is we support all the same things all over the place, indeed. Very good. So let me start the demo. Yes, here you go. So hopefully it's visible. I hope also from the back seats is visible as well. So what do we have here? So here I want to analyze one specific service endpoint where I got notified that I've got a problem. So I go in the traffic analytics, which has been enabled in my fabric. In this case is ACI, but it would be the same for an XOS. And I filter for this endpoint, 10.0.1.100. And I see there are two services offered by that specific endpoint. One offered on port 1433 and one 8080. Both have some traffic analytics score which is not healthy. One is major, one is warning. So two different things. So let's start to drill down. So let's go in the first one. Right. So here I'm on port 8080, and I see that the reason for the drop is a policy drop. And I see this is consistent all the time. So what that means, policy drop in general, a contract is denying, right? So it's something wrong in my configuration, most likely. The second one, port 1433, I see only one was dropping packet because of forward drop. So it looks like it was a transient problem, right? But let's analyze it more. So I start with the second one, 1433, a troubleshooting session. So I say, please, for the next few minutes, analyze all the traffic for that specific service and tell me more. Tell me all what you can about it, right? And I let it run for a couple of minutes. Meanwhile, I go back to my 8080 service, right? So the one that was doing policy drop, and I try to understand what is the problem with that. So I run a connectivity analysis between this 8080 service and my client, and I let this run. So I start seeing where those two endpoints are located. Again, this will take a couple of minutes. So while these two things are running, the flow troubleshooting and the connectivity analysis, I go in search and explore, right? So I use yet another tool that Camilo just showed before, and I ask ND, can you tell me everything between my client and my service endpoint? What is the configuration that I've done in my fabric? Well, here I can see very clearly that the policy was only allowing port 1433, but not port 8080. So apparently I forgot to do a contract, to add a contract for connectivity. And when I go back to the connectivity analysis, indeed I can see that the leaf is dropping the packet. So here I have clearly, if I click on the leaf, I see security drop deny, right? So the packet is being dropped because of a contract, right? So in few seconds, I had 3 or 4 different tools that very easily, help me to spot the problem, which in this case is fairly, simple at the end of the day. I forgot to place a filter, a contract that was allowing my communication to that specific service endpoint, right? And I also confirm from an ELAM capture standpoint, if that is even, required, that the contract is dropping the packet. This is coming from my ASIC. So, right, so the ASIC is telling me that there was a problem there. So it's also interesting to see that the connectivity analysis spotted that, that this endpoint was trying to connect, any leaf, so it was bouncing from one leaf to another, and the drop was happening, by the way, at the source level, so from an ingress standpoint, which is typical behavior, when you're talking EPG to EPG and you apply a contract in ACI. So 88 is fixed. I know that I need to add a filter, and I need to do something about my contract. Now let me go back to the other service, 1433. So this one I had a transient problem. I want to know and understand if this problem is still occurring. So as I said before, I kept monitoring for a few minutes this specific connectivity for service 4033, and I see that the flow record. So in the last minutes where I was analyzing this, I had no more problems. So the traffic was flowing. I could see that all the paths undertaken between my source and destination were going exactly, through this leaf spine, leaf connectivity. I could see, the latency, all more information about the number of bytes, the packets that were sent, what was received, what was ingress, what was egress from each and every leaf that I got there. So I can drill down and I can really understand, okay, was it a transient problem that was happening in the past and now is everything is fine, or is still ongoing, right? So this confirms that now, the problem is gone. So it was a problem in the past that I can, still eventually troubleshoot and verify why it happened in the past, maybe checking my route table and checking and verifying my why I got my forward drop. So this is concluding the first demo. We saw again in few seconds, in few minutes, this interesting amount of different tools that help me to troubleshoot a flow and a problem with my connectivity or specific service endpoint in my data center. The second one is about policy-based redirection. Who is doing policy-based redirection with ACI in the room? Quite a few. You know how complex it is, right? So policy-based redirection, for who doesn't know, is a way in ACI, which is now available also in NXOS, by the way, with GPO, to redirect the traffic with policy-based, indeed, to a service chain, for example, to a firewall. So in this case, what I'm doing is I'm setting up between my client and my server a policy-based redirection that says, okay, send all the traffic to my firewall. Well, am I really sending the traffic to my firewall? I'm responsible for this. My manager is telling me, assure that 100% of the flows are going through the firewall, not even one should bypass the firewall. If one bypass the firewall, you're out, you're fired. Okay, what do I do? How do I troubleshoot? How do I make sure that I'm always going through the firewall with my connectivity? So Nexus Dashboard can also help you there, right? So what I can do, I can start, the first tool that I use is Search and Explore. Tell me what's going on between my client EPG and my server EPG. Am I having a contract which is doing policy-based redirection? Well, good news, yes. There is a contract between, where is it? Client and server. It's actually allowing port HTTP and port SSH and ICMP traffic, and all the contracts are having a redirection. Redirection which is going to my firewall, right? This is the leg of my firewall. And I can see also the subnets. So I can see the source subnets, the destination subnet, and the firewall subnet in there. And finally, also the IP addresses, the IP of the client, of the server. In this case, I've got only 1 and 1. And also the IP of the firewall, right? So at least from configuration, Nexus dashboard seems to confirm that the configuration is right. And in fact, ACI tells me the same. ACI has server and client TPG, the PBR from a contract standpoint, which is there, right? So Nexus dashboard seems to tell me the truth, at least from what ACI also tells me. The firewall is telling me that there is some traffic going through the firewall. This is my ASA, which is telling me I see traffic between your source and your destination. But okay, I don't trust it. Tell me more. I want to see in the switches, the flows that you see, how are they behaving? So what else can I do? Well, I can go here. I can go in my IP address, in my endpoints, right? So this is the service side endpoint. And what I can do, I can check the flows which are related to my service endpoint, right? So in this case, I see that 67.100 is exposing indeed the service, the web service on port 80. I see indeed there is ongoing traffic. So there's a lot of traffic in terms of bytes which was sent in the last hour or so. I can obviously, go back in time and check even more history in the past. And here I can say, okay, tell me for the next 20 minutes, all that you know between this source and that destination. I want to know all the packets, where they are flowing, in each leaf and spine, where they are going, right? So I wait 20 minutes. That's why I recorded the demo. I don't want you to stay 20 minutes there, right? But so I wait 20 minutes, and then I go and check the records. So all that has been collected there. And if I check the records that have been seen by Nexus dashboard, I can see very, very easily, if I scroll down a little bit, that the path seen between my source and the destination is going only through this path. If I had multiple, I would see multiple topologies in there. So in this case, I can ensure that for 20 minutes, the traffic only went from these endpoints, passing through the leaf, spine leaf, the firewall, and then again leaf, spine leaf, and the destination endpoints. And I can also see, by the way, information like the two segments between source and firewall and destination, with the latency between those two segments, right? So I'm happy, my manager is happy, everybody's reassured. I can say that policy-based redirection works fine, and I'm sending all the traffic all the time to the firewall, right? So no deviation from that standard. That concludes my two little demos, and I go back to Camillo. I think he has got two more for you, hopefully as exciting.
Yeah. All right. Now, this next demo is around pre-change analysis. Now, we didn't really speak much about pre-change analysis and compliance because I was going to show you it here. But the idea is that we can configure NDI to track our configuration against compliance rules. So in this demo, for example, I'm going to show you that I have a few compliance rules that are of different types. So here you can see that some are of type of communication compliance, and some are configuration. Now, communication, it's all around, well, communication flow, having the ability or not the ability to speak between two EPGs. In here, we say, I want two EPG to be able to talk. And then the configuration one are more around, like, is my configuration following a specific set of rules? Now, when you look at communication compliance, it always tries to tell you the direction of the flow and what is the rule that you want to enforce. So in here, we are going to show you that the EPG in the pair can or are not able to talk in the A to B and B to A direction. So source to destination, destination to source. And then when we scroll up, you will see that it also tells you that we're speaking about EPG1 underscore EPG and EPG2 underscore EPG. And then we have the same rule also for TCP port 443. So now we go on ACI, and if we take a look at our application, you can actually see that from the topology, there is indeed no contract in between the EPG, and that's why we're going to triggering this anomaly, this compliance anomaly, because we want to have this communication allowed, and we don't have it. So here now we're going to go, and we're going to change our Ansible configuration to then run a CI/CD pipeline to push this new configuration inside ACI. As part of this change, we're also going to create a new VRF with a new bridge domain and a few new pieces of config, right? So we're going to go and we're going to do a commit of our Ansible playbook or our Ansible configuration inside our Git repository. And the moment we're going to commit the code inside, this is going to trigger our CI/CD pipeline to start running. Now you will see here in a moment that now our CI/CD pipeline is starting. The first step that now is like in waiting would be like doing a Git pull of the new code, and then our pipeline will start running. And the first thing that we're going to do is the pre-change validation. Now, what is a pre-change validation? It's a way to simulate how the impact of this configuration change will be on our running ACI Fabric config without actually pushing the configuration. So here you can see that now is submitted. So it's being analyzed. It will take a few minutes. Depending on the size of your config and of your change, it takes more or less time. But eventually, here it finishes, and we get a fail. Now, why did we get a fail? Well, we can go and we can take a look at our Ansible playbook, and you see that it gets an error saying we are violating a compliance requirement. So now we can go back into NDI and look at the detail of our pre-change analysis. When we open it here, we can take a look at a feature called delta analysis. Now, I'm going to pause the demo just 1 second. Now, we didn't speak about delta analysis. But what is delta analysis? Is a way to take 2 points in time of the status of our fabric and compare them. Kind of a diff, if you want. Now, we can do a delta analysis before and after a change request, or say it's 2 a.m., you make a config change. Did I break something? Well, you can take a snapshot of your config before the change, a snapshot after the change, run a delta analysis, and it's going to tell you what did you change, and also how did the change impact your configuration. Right? Now, the delta analysis can also be applied between a real config snapshot and a simulated one. So here, as part of the pre-change analysis, we simulate the impact of a change, generate a virtual ACI config, and then do a delta analysis between the virtual or the future intended config that you want to have and the last snapshot that you have. When you do that, and we go into the new anomalies, it's going to tell you that there is a configuration compliance violated. And the violation is that I'm not following the naming convention for my VRF. It's one of the many things we can change, naming convention. And in this example, that's what is wrong. And now we can also see what are the cleared up anomalies. And here, the cleared up anomalies are the one of communication, because our change was correct in opening the required port and adding the required contract, but we messed up and we used the wrong naming convention for the VRF. So now we can go back into our Git or into our code, fix the VRF naming by adding the underscore VRF, and then we can rerun this whole thing to then push the new configuration. And as you will see in a moment, once you do the commit, the same CI/CD pipeline will be triggered, and this time the pre-change analysis will be successful, And once the pre-change analysis is successful, then the next step in our CI/CD pipeline would be to actually run that Ansible playbook against the real ACI fabric and push the configuration. Because as of now, no configuration has been pushed on ACI, right? We're just simulating it. So here you will see there is a new analysis running. And most likely, now you see the stage, the PCV pre-change analysis is correct. There are no new anomalies present, and now the configuration will be pushed into our ACI fabric. Now, as part of this demo, the deployment stage is manual, so it allowed the user to actually select if they then want to go ahead or not and push the config. You can also say if the pre-change validation is successful, push. Probably you still want to have a human to click yes, but up to your preference. And now you can see that now the configuration has been pushed in here.